Example 5. Find all solutions of sine squared x minus sine x plus 1 equals cosine squared x on the interval from 0 to 2 pi. Now first, when I look at this, I notice this is in the form of quadratic in the sense that it's three terms and the powers are decreasing. Sine squared, sine to the first, and then no power whatsoever. It's in the old form of ax squared plus bx plus c. Now the thing is, when we did quadratic, or trinomials rather, we would want to solve it as equal to 0, which this is not. So here's the first thing. I want to combine this over, but notice that this is sine and this is cosine squared. So let's think about the formula chart here. As I look at it, I'm going to go to cosine squared, and remember that cosine squared shows up on the Pythagorean identity as being with sine squared theta plus cosine squared theta equals 1. And so let me pull over now this, and we'll write it over here. So we have from the notebook that, or from the formula chart, sine squared theta plus cosine squared theta equals 1. And if I wanted cosine squared by itself, like I have here, I could find out that cosine squared theta would equal 1. How would I get the sine over there? I would have to subtract it, minus sine squared theta. So that's what I'm going to do here, is I'm going to replace cosine squared theta using the Pythagorean identity. And I'm going to say that this is 1 minus sine squared, and that's an x, not a theta this time. So I have all this here, sine squared x minus sine x plus 1 equals all this. Okay, now let's set this equal to 0. So to set it equal to 0, I need to move two things. This positive 1 needs to be subtracted, and I need to add sine squared x. Now, when I combine all these terms, these go away, and over here I'm left with 0. This goes away, and so I have 2 sine squared x minus sine x, and that equals 0. And so now I'll just factor to solve. So I'm going to factor this. This has GCF, so I want to factor by GCF. What do I mean by that? They both share sine x, so I will factor that out. So if I have sine x, it's kind of like reverse distribution. If I divided this by sine x, I'm left with 2 sine x. And then here, sine x divided by sine x is 1. That equals 0. Okay, so I'm going to shift this over just, well, no, it won't let me. I'm going to take this over so you can see a little bit better how I got this. So the sine x, I took 1 out from here and here, and so this became the 1, and this became the 2 sine x. And now we solve. So I have that sine x equals 0, or I have that 2 sine x minus 1 equals 0. And to solve this over here on the right, you would add 1, so 2 sine x would equal 1, or sine x has to equal 1/2. Now let's consult our little unit circle. I'm going to put it over here. So we have an x and y axis. We need to have a circle on there. So I'll put a circle, and I'll do this in purple. Remember, this is a unit circle. And so here on my y-axis, I have a y value of 1 there. This point would be 0, 1. This point would be 1, 0, just to remind you of what's going on. Here's my x-axis. Okay, I want to know when sine is a half. That means y. Sine is y. So when is my sine value a y? Or 1/2 rather, they would be over here. So my sine value would be 1/2. It looks like if this is 0, 1, and this is 0, it should happen over here. And we'll think about on our hand trick where sine is 1/2. The hand trick would say that the y value is 1/2 when you have one finger on top. So I'm looking at the back of my hand right now. I need sine to have one finger on top. So I'm bending my ring finger. My ring finger is referring to pi over 3. That would be the spot right here. So this happens at pi over 6. I don't know why I said pi over 3, because thumb is pi over 2, index finger pi over 3, middle finger pi over 4. Your ring finger is pi over 6. So it would happen here. And since I go all the way from 0 around to 2 pi, where this is pi, this is pi over 2, and this is 3 pi over 2. We know we also get a y value 1/2 over here. Y would also equal 1/2 somewhere over here. And it'll be the same pi over 6 finger, but now since it's in the second quadrant, it's almost 1 whole pi, which means that this would be just smaller than 6 pi over 6, so it is 5 pi over 6. So those are the two answers here. That would mean that x equals pi over 6 or 5 pi over 6. That's when you have a y value of 1/2. And then for when sine is 0, that means the y value is 0. You have one here at 0 and another at 2 pi. So I'm going to draw this now in green here and here. We would also have, that would happen when we have 0 and pi, since sine is y. So those would be the 4 locations. This would be 0 and these 4. Again, we could check this real quick by graphing. So I'm going to go over here and press menu, graphs, and the left side I want to do as trig sine. Now if you do the squared, remember on the calculator you have to put the squared in the outside. So sine squared minus sine x plus 1. Okay, and my other equation is simply cosine squared x. Cosine x, and put the squared on the outside. And I want to know from the interval from 0, so this is the x-axis here. I'll do this just so we can see just to the left of 0. I want to put in negative 0.2. That way you can see just a little bit over there. And over here, this should go to 2 pi. 2 pi. I'll press enter. And so I'm looking for any time these are equal. So we go menu, analyze graph. I'm looking for the intersection. So we should have one right there at 0, which we do. Menu, analyze graph, intersection, and then we should have one at pi over 6, which we can check that on your own. If pi over 6 is equal to that, so 3.14 divided by 6 and see if that's equal. You come over here. There's another intersection. Menu, analyze graph, intersection. We now try this one. 3.14, that means pi is the value. So we have 0 and pi, those are clear. And then we had these two. And we do not include 2 pi. So over here, you would not include the 2 pi as part of it. Menu, analyze graph, intersection. See, I can't show it because it cuts off. And so we would not include that one. So these would be your answers given here.